Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama-Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Devin.
I'm Kiyomasa. For math homework help call in Bakersfield, 636-4357. Everywhere else, 1-866-636-6284. The Do the Math email is dothemath@kern.org. We're online at dothemath.net. And on social media, Facebook, Instagram, Twitter, and YouTube.
There you go. Nicely done. Twister.
We're
Have you
on
ever played
Twister
Twister?
today, all day.
Have you played that?
Yes.
Oh, good. So I didn't know if that was going to be one of those old ones where people might be like, you guys are in your 50s and 60s and 70s. That's how, old you guys
It's
are.
always there, cheap to make, good price.
So, Kiyomasa, where do you go to school and what grade are you in?
I go to Highgate Elementary, and I'm in 6th grade.
How long have you been at Highgate?
For about 3 years.
Okay, because it's a relatively new school still, isn't it?
Yes.
And what do you like about this? Because you obviously had been to another school before that. Is there anything that you particularly like about Highgate?
The teachers are really nice and caring, and I think I get a pretty good education there.
All right, good. Well, you know what? That's the important thing, that you have somebody that is caring about your well-being while you're at school, because you're there most of the day, right?
Yes.
All right. What kind of math have you been doing so far in 6th grade so far?
In 6th grade, I've been doing like algebra, and like we're starting to get into a little bit of algebra in class.
So what kind of things are you doing? Do you remember offhand, like some of the types of problems you've been doing, or?
We're kind of like starting to get into like exponents and stuff.
Okay. So you're pretty comfortable doing all of that?
Yeah.
All right, good. Well, we got some excellent problems for you to work on today. But right now, you and I are going to take a look at today's social media problem of the day. You ready?
Yes.
All right, let's take a look at the monitor up here. It says, what is the answer? 5, and then there's a 2, plus 3, and then a little 3. So what do the little numbers mean compared to those big ones?
So
you were just talking about what you were doing in 6th grade.
The little
math,
numbers
right?
represent the number you times it the same number by itself. So for example, 5 times 5, that's 5 to the 2nd power simplified. So 5 times 5 is 25.
Okay, so let's first of all just take a look at that again. So it's 5 times 5. So the little 2 is the exponent you were talking about.
Yes.
And you said to the 2nd power. So the base number 5, you're going to multiply that by itself. Instead of 5 times 2, it's 5 times 5.
Right.
Okay. So what about that second part?
That second part is 3 to the power of 3, so you're just multiplying 3 times 3 times 3.
Okay, so instead of saying to the 2nd power or to the 3rd power, is there other vocabulary you can use? Have you heard yet what you can call those? Instead of saying 5 to the 2nd power, we can say 5. Have you heard squared?
Yes.
And what about the 3? Do you know what that's called? If we say 3, instead of saying 3 to the 3rd power, it's 3
Squared?
cubed.
3 cubed.
All right, so if you say squared, it's to the 2nd power. If you say
Right.
cubed, it's to the 3rd power.
Okay.
Okay, so let's go ahead and see if we can figure out what the answer is. So you said 5 squared was 25.
Right.
And what is 3 cubed?
Well, 3 cubed is 3 times 3 is 9, and then 9 times 3 is 27. So 25 plus 27 is 52.
Good. So let's take a look at some of the other answers. 19. Why do you think 19 would be selected?
19 might be selected because they would do 5 plus 5 and then 3 times 3 or something.
Good.
That's 10 plus 9.
Right, because if you go 5 times 2, you get 10. 3 times 3 is 9, and you just do that. That's how they could get 19. What about 34?
34.
Because there were 2 answers that were very popular today. All right? And you came up with 52, and we'll see if that's right in a moment. But a lot of people selected 34 also.
34.
So remember, 5 squared was 25.
Right.
And then somebody might go 3 to the 3rd power and just go 3 times 3 maybe. is 9. So 25 and 9 would be 34.
Right.
Does that make sense?
Yes.
Okay. So D14, how do you think somebody might get 14?
14, they might,
Kind of hard why they put these answers on there, right? But
Yeah.
think about the 9, 3 times 3. Somebody might just go 3 times 3 is 9. And they might just go, I don't know what the 2 is. Let's just go 5 plus 9 is 14. Make sense?
right.
Who knows what they were thinking, right? But that's one way I could think of to get 14 and have it be a wrong answer.
Right.
So after we've gone through all of these, what do you think is the correct answer?
B or as 52.
All right, so you think 52 is it. You feeling good about that?
Yeah.
All right, let's take a look and see if 52 is indeed correct. 52 is it. There you go, dude. First problem done, all right?
right.
That wasn't that difficult, was it?
No.
It's a good thing you've been working on exponents since 6th grade then, right? All right, very good. 636-4357 is the phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, in studio with us for today's Math in the News, we are fortunate enough to have Richard in with us. Nice to see you.
Thanks for having me.
So you are with the Kern Economic Development Corporation.
That's correct.
So I got that all out correct?
Yes.
All right, good.
And
So-
actually, I have a problem for you. What weighs more, a ton of bricks or a ton of feathers?
Well, you know what? Since they're both a ton,
Okay.
they're equal.
Okay, sorry.
But I would rather carry the ton of feathers because it would be a little softer, I
Okay.
guess, all right?
I can't stump the host.
All right, so now I see where we're going to go with
Okay,
this
okay.
afternoon, all right? You come in with a problem already. Nice going, nice going. All right, so explain, first of all, what is the Kern Economic Development Corporation?
So we market the county as a good place to do business, so both for investment coming in as well as growth within the region.
Okay, and your role with the corporation?
Yes, I'm the president and CEO of the Kern Economic Development Corporation, and we're funded by public sector, private sector, as well as education.
And has this been around for a long time,
Yes.
or is it relatively new?
Since 1988.
Okay, since 1988, so it's been around for a while. And you are the president.
Yes.
Have you come in as that, or did you work in other areas
Yes,
in the
so
corporation?
I actually know, the economic development trajectory is not really clear, right? I basically was fortunate. I studied actually at Georgetown University and got my graduate MBA, American University. In 1995, I started in economic development in Seattle, Washington.
Okay.
And then I actually have 25 years experience in the industry. I've been here 17 years.
Oh, good.
And I love promoting Kern County, and we have to all be better ambassadors for the amazing things we have in our own backyard. We're number 4 for STEM jobs in the country, and we're the 3rd most diverse economy in the U.S.
So I was going to say, because we have a great deal of things going on and resources and a big economy. I mean, we're
Yes.
the size of a state.
We are
And we
Connecticut or Rhode
produce,
Island.
like countries would produce in some cases.
Our GDP is actually also the largest in the San Joaquin Valley. We're larger than Fresno. We're at about $50 billion. I was just in Mojave at the spaceport yesterday. 100 companies basically creating the future of space tourism and innovation.
Right, because that is at the forefront right now. That's a lot of things that people
Yes.
are into. Let's take a look at the graphic that is on your webpage right here. So the largest economy you just said about in the San Joaquin Valley,
Yes.
number 3 in the nation.
Yep, we put US stats.
And I don't think a lot of people realize this is the breadbasket.
Well, we always say we power the world, we feed the world, and we defend the world.
So some people might be going, all right,
Okay.
I understand those 3 things. So power the world.
We are the energy capital of California. We have a majority of the renewable energy as well as oil and gas.
And that's a big thing that Bakersfield has been known for, and Kern County.
Yes, Kern County is, we want good jobs, we want good investment. Last 2 weeks ago, Hard Rock had their groundbreaking.
right, yep.
So we'll have a casino hotel that's bringing new money. And the thing about economic development, you want new money to come into the economy. So that money would not have come in without this project in our
So
backyard.
it's good to grow what's here, but you also
Yes,
want
the
new coming in.
balance is, we know that 80% of jobs are created from local companies, but typically what makes this news, splashy news, is a new investment coming
Right.
in. But it's that mix is so important.
And some of the other, I mean, we can take a look at the graphic here and some of the stats are on there. What are some of the ones that you try to emphasize or you see that are most important when talking to people?
Well, I point out right away we're number 3 in the country for ag, and the other 1 and 2 are actually in the valley. So the Central Valley basically has a majority of the top ag producing counties. But most people don't understand we're a rich STEM region. Our STEM jobs don't look like most areas like Seattle or Boston. You can have a 4-year high school degree and be successful in a STEM career. You can have a PhD or a bachelor's, but the point is there's several career pathways. So CTech, Career Tech,
I was going to say, because you do a lot with CTech.
Yes, and our foundation actually partners the high school district on the annual Career in STEM Expo.
And that is a well-attended event.
3,000 to 4,000 kids, 130 employers, but we need to show the kids the opportunities in their own backyard. A lot of times they want to leave, be a professional athlete, right, or a singer. Okay, maybe they can, but what if you look at see the opportunities here?
Right, and because that's a natural thing, I think, for a lot of students. They want to go out and kind of like make their way somewhere. But then if you take a look at the opportunities that are right here, you don't have to go.
And then
you've got people actually coming in.
That's it. And what we actually, our foundation created KIC, Kern Intern Connections. So we pair these recent high school grads with local employers, because that's the number 1 attribute their employers are looking for. Did this student have a paid internship?
And there's a publication that you guys have, and we'll just go ahead and hold this up for the camera. But that's where you can find information like this.
Yes.
In this publication,
on our
as
website.
well as what else?
Well, that talks about basically the selling points for Kern County. Why would you want to locate here? Also, live, work, and play, not just for a job, but for the relative, cost of living and the amenities here. So that we need to understand the rich variety that are available.
Because I know there's a lot of people who say California is very expensive, and it is.
Yes.
But as far as Kern County compared to California, it is not.
Yes, our cost of living is about 8% higher than the U.S. average. But you go to L.A., that's 160%. So we want to make sure the American dream, we know the American dream is still possible here. And that's why these STEM jobs offer that opportunity to purchase a home and so forth.
And it's great that you've done a lot of work with CTech and stuff, and I know that you guys have a video series coming out.
Yes.
And this is also talked about on the website in some of the episodes. So tell us a little bit about what you've got going on.
So the first thing to note too is we use local providers. So our market overview was a local graphic design firm. These videos are produced by a local company. And so it's where business is boundless. That's our tagline. We started out in East Kern. We went to Mojave Air and Spaceport, so we have actually 2 videos, both with the general manager, CEO, and Stratolaunch. Stratolaunch, do you know how long how wide the wingspan is?
Once you tell me, I will.
How many feet? Do you want to guess?
The wingspan?
Yes.
I'm going to go 300.
384.
Oh. Dude, you got to be
go.
rocking that right there, right? I'm going to do 300, 384.
384.
Right there. I didn't go over either.
Yeah, and it's longer than a football field.
Now, if you had asked me to give you the exact, I probably would have said 381.
Well, you were what percentage? How close to you were the answer? How percentage were you off?
Well, it was 84.
Maybe we could have the student come
so
back on.
Yeah,
okay.
20% maybe. So we'll have Kiyo do that later.
Yes,
on.
we have. And then we also, our last episode was Triassic Vineyards. We have some of the best wine in the country, if not the world, in Kern County, and it was just actually designated an AVA, American Viticultural Area. So we have award-winning wineries, right? Of course, you can drink it, but not all the audience today.
So for people that want to find out a little bit more, the website they need to go to?
www.kernedc.com, as in Kern Economic Development Corporation.
All right. Well, Richard, we certainly do appreciate you taking some time to come down and visit us.
Thank you.
So once again, the publications are out. You can check out the video. And right now, what we're going to do is we're going to check out one of those videos right now.
There's airports, then there's air and spaceports. On today's episode of Where Business is Boundless, we'll explore the gateway to the final frontier, where air and space collide, at Mojave Air and Spaceport, and how vital it is to the economic development of Kern County. Now follow me on my journey where I see the sky is not the limit here at Mojave Air and Spaceport. Today we're going to be exploring the Mojave Air and Spaceport with our friend Tim.
Hey, Lise.
Hey, Tim. How's it going?
Good. How are you doing?
Good. How are you?
Good.
So tell me a little bit about what you guys do here.
We do a whole bunch of various interesting things. We are a horizontal launch facility and a licensed spaceport. We have operators that do horizontal launches like Northrop Grumman, Stratolaunch, Virgin Galactic, Virgin Orbit. But also we're a general aviation airport, which is where we have our tenants that come in with design concepts that they go ahead and build and test here at Mojave as well. So a very exciting and interesting spaceport.
So you guys do a lot.
We do a lot.
To sum it all up.
Absolutely.
In 1942, the U.S. Marine Corps took over the field and vastly expanded the U.S. Marine Corps Auxiliary Air Station here in Mojave.
So Tim, tell me a few things about Mojave and what year was it established?
Well, the airport itself, it was established in 1976. Dan Sabovich, the original general manager, saw this airport which was inactive. It was being used as a Marine Corps Reserve Air Station. It was inactive for years. And he said this would be a great location for testing aircraft, much like what they do at Edwards. So around 1976, when East Kern Airport District took over the airport and started building it to what it is today.
Wow. How about we go check outside?
Yeah, I got a plane outside if you guys want to check it out.
Yes, definitely.
Okay.
So Tim, tell me a little bit of something about this plane.
Well, this is a Piper Warrior. It's 108 horsepower. It's used mostly for training, but also for some cross-country and some leisure flying. So it kind of embodies, I think, what we're trying to accomplish here at Mojave, which is providing a general aviation environment in addition to all the flight testing and aerospace testing that we do.
So since the expansion here at Mojave, what is the economic impact that you have seen?
There's a tremendous economic impact here locally in Mojave, but also in Kern County as a whole, because we provide for at least 3,000 jobs. There's a tremendous economic impact from this spaceport.
So exactly how big is this sleeping giant?
It's 3,300 acres.
Wow, so it's not tiny for sure.
No, especially for an airport. We have plenty of space.
So what are some of the programs that you guys are trying to move here into Mojave?
Right now, with space and development and exploration of space, your small startups are the gold. It's not the big fish that we're traditionally accustomed to in the aviation world. It's the small individual entities. So trying to find a way to get them onto the airfield, lessen their overhead as much as possible, and so that they can start working, designing, building and testing their equipment, and then grow with the airport as they need to. There's a very bright future for Mojave outside of just the flight testing, rocket testing, and general aviation.
Mojave Air and Spaceport has been a consistent in breaking records and has pushed the aerospace barriers. Now, how does this help with the community here?
Well, so this is very unique. The spaceport actually owns and operates this air traffic control tower, which is exceptionally unique in airports. Usually it's the FAA that operates it, or the FAA operates it through a contract tower. We're a non-FAA contracted tower. So that means that our air traffic controllers are employees with the airport, and the airport pays and maintains this air traffic control facility because we feel there's so much value in having air. So have a little bit of a surprise for you. If you want to come along with me, we can go flying.
I'm a little nervous, but I like a challenge.
You have nothing to worry about. I'm a flight instructor. I've been doing this for 20 years, so you're in good hands.
There's a bright future here at Mojave Air and Spaceport. Jim, thank you for showing me around and flying me around.
Oh, it's been a blast.
See you guys next time on Where Business is Boundless.
And once again, a big thank you to Richard for coming in, talking about KEDC, the Kern Economic Development Corporation, and all of the different things that encompasses, and how big Kern County is as far as opportunity right here in our backyard.
Don't have to go too far.
So anything that you think you might want to do when you get a little bit older, you could probably do it right here in Kern County with a lot of success. Kiyo is a 6th grade student from Highgate Elementary. And you ready to start getting to work?
Yes.
All right, head on over to the board. You and Devin are going to start working on this. And we're going to take a look at the problem, first of all, underneath the camera here. This is the problem that you were presented with. And it says, determine the dimensions of a tile in the patio. And we can see that the patio is rather large. And Devin didn't put all of those rectangles out there, but he put enough that we can solve the problem. And we know that the whole one side of the patio is 8 feet in length. But he's got 1/4 of the patio drawn out. And we can see that he's got the bottom half. And we know that if the whole thing is 8 feet, we know that the one part of it is 4 feet. So you guys are going to go ahead and use that information and see if you can figure out the size of one tile.
So just to kind of summarize, we had this larger diagram that would be 8 feet tall, and we took 1/4 of that. And if we know that this is 1/4, we know that the height of this is 4 feet. And I kept the original, just kind of general diagram of this as a reference so that we can figure out some things. But our objective is to find out the dimensions of one of these tiles. So when you hear dimensions, what does that mean to you?
Shapes.
Okay, so if I have, so like I get what you're saying. When we think of dimensions, like if you think of a 2-dimensional shape, you're thinking of something that's flat.
Flat.
3-dimensional shape, we're thinking of something like a cube. So like a
Right.
square would be 2-dimensional, cube would be 3, which is why we use squares and thirds for those powers and say cubed and third and half, quarters. But in regards to 2-dimensional shapes or anything that we're measuring, a dimension also refers to something that can be measured. In the instance of polygons, such as rectangles here, a dimension can refer to length as well as width. So when we're being asked to find the dimensions of a shape, what we're really being asked is to find the length and the width. So, we want to figure out how long and how wide each of these tiles are. Since all of these tiles are the same shape, they have the same length and they have the same width. Now, with that information, how do you think we could start out figuring the dimensions of just one of these tiles?
Well, now that you think about it, we could find out the area of each rectangle and then determine the area of 4 feet.
That's a really interesting approach. So your mindset is, well, I know that there are 8 of these rectangles in this 1/4 of the larger piece here. So if I can find out the area of this larger, of this quarter, or even the area of the largest one, I can work from there.
Right.
Okay, well that's really interesting. So let's go back to this larger piece then. Now, if we know that this is 4 feet high, and if we know, going back to the original diagram too, if we could. I
Let me
think it's on
turn it
the other
over because
side
I've
there,
already
right?
got the other problem
Spoiler
going.
alert for
But
later
let's
on
take a
today,
look at
folks.
this again.
Let's take a look at this original diagram. What do you notice about how this is laid out that you might be able to infer based off of the information that we see?
Well, there's two parts of the patio that's the same, and
Right.
then there's another 2 that's different from the other 2.
So in terms of how they are laid out, how they might be rotated or translated, that's on point. We know that that original rectangle is 8 feet tall.
Right.
Is there other information we can infer as a result of that by looking at this? So take a look at the right half. Here's what I'm thinking. Take a look at the right half of this rectangle,
Okay.
right? If I know that the height is 8 feet,
Right.
can I figure out what the length of that rectangle is?
Well, we both know that half of the 8 feet is 4 feet, so one giant rectangle or one section it has to be 4 feet,
Right.
or the area of 2 feet.
So I'm wondering if this right half of this bigger rectangle is actually a square. Looking at the way this is laid out, and if that's the case, that gives us information on kind of the top half of this overall rectangle, right?
Right.
Because if this is 8 feet, and we're going to presume that each of these sides is a square, what does that mean about the length of this section here?
That it's got to be smaller.
Well, it's going to be the same, right? Because if this is
Right.
going to be a square, this is going to be 8 feet as well. And if that's the case, then what about this length here? Since these are going to be similar in how they're laid out. If this part of the length is 8 feet, what is this going to be too?
8 feet.
8 feet. So the overall length of this looks like it's going to be 16 feet. Now, we're only talking about one of these, right? We know that the height is 4. What would that tell us about the width of this one then?
Then this one's got to be 8.
This can be 8 feet. All right, that's really interesting. Now, your approach was, I want to figure out the area of this piece, and then I can divide that by 8 to find the area of one of these, which can be helpful in finding the dimension of one of these in terms of length and width. So let's do that. What would be the area of this larger rectangle be?
Well, for what we can see, 8 times 4 has to be 32.
So the area is 32, and if we divide that by 8, what does that give us for the area of one of these triangles?
4.
4, and how would we label that as a unit?
We would do that as
So we think about this as 8 feet times 4 feet,
okay.
or one of these would be 4 of those units, right? Would it just be a single foot as the unit, or how would we refer to that?
It would be 4 feet.
4 feet. Now, feet is a distance of measure. How do we represent that as a measure of area?
Area, length times width.
So we're talking about this as a dimension, right? Again, we're talking about if it's a square, if it's a flat dimension, a flat space, an area, we're talking about square feet in
Right.
particular, right? Because we're essentially talking about how many feet across and how many feet wide. Now, that's great. We know that the area of one of these rectangles is 4.
Right.
That's helpful. Now, let's see if we can figure out some other information to determine, and maybe we bring in some algebra to figure this out, right? Maybe we can figure out the length and width of one of these rectangles. So what could you try to figure out the length and width of one of these?
We could try dividing 4 divided by 8 to get 0.2 because it's 4 feet, and you could divide it by 8 feet, and we could determine the amount of feet for like each square, which could be 0.2.
That's possible. Now, if we do, are you saying 4 divided by 8? If we represent that, just for the sake, because I heard you say 0.2 there. If we do 4 divided by 8, represent that as a fraction.
1/2.
That'd be 1/2, so it wouldn't be 0.2, right?
Right.
Now, there might be another way to approach this. And perhaps we can look at this from an algebra approach. Okay, so there are some things that we don't know, but some information that we do know. Let's take some of these dimensions here. So for example, I'm going to represent the length of this rectangle as L.
Okay.
Okay, I'll use I'll use an uppercase L here. And I'm going to represent the width of one of these rectangles as W.
Okay.
All right? Now I know that L times W is going to equal 4 square feet.
Right.
I also need to figure out ways to represent some other equations like this I could form together. So for example, if I have 3 of these lengths together, what will that equal?
24.
Well, I don't know that each of these is 8 feet yet, but I know the total is 8 feet.
Right.
Right? So 3 times L will equal 8 feet.
Right.
And we're going to let you guys keep working on that for a little
Yes.
bit, because this is a lengthy problem.
Get it?
But for
Get
some
it?
great work that you've done so far, you've got yourself a meal courtesy of our friends at Broken Yoke Cafe. So congratulations on that. Hopefully you have an opportunity to go check that out and get some food. And you were just talking math, and that's what we're going to do right now. We're going to talk a little more math.
Hello guys, my name is Pranshi. I am a 4th grade student. I go to Stockdale Elementary School. Today I will talk about multiplication. Multiplication is one of the basic arithmetic operations. Multiply means repeated addition of same sizes of groups. Let us take an example for repeated addition. 2 plus 2 plus 2 that is equals to 6. But we can simply do 3 times 2 equals to 6. The product will be the same. Now let us take an example for multiplication. Suppose I have 2 groups, and in each group I have 3 dots. So I can simply do 3 plus 3 equals 6, or 2 times 3 equals 6. The 2 is called the multiplicand, the 3 is called the multiplier, and the 6 is called product. Now I would like to tell you the properties of multiplication. When you multiply any number by 0, the product will be 0. 5 times 0 equals 0. When you multiply any number by 1, the answer will be the number itself. 5 times 1 equals 5. Changing the order of number does not change the result. 2 times 3 equals 6, or 3 times 2 equals 6. Changing the grouping of number does not change the result. 2 times 3 times 2. That is equal to 3 times 2 is 6. 6 times 2 is 12. So the product will be 12. 2 times 3 times 2. That is equal to 12 because 3 times 2 is 6. 6 and then 6 times 2 is 12. So we got 12. Now I would like to tell you the trick for multiplication, but that trick is called 1 cross 1, and it is a one-step method. But first I'll tell you the regular method we use every day. 23 times 21. 3 times 1 is 3, 2 times 1 is 2, 0. 3 times 2 is 6, 2 times 2 is 4. That is equals to 3, 8, 3. That means 3, 8, 4. But now it's a 1 cross 1 method. I'll take the same number. First we multiply 3 times 1 is 3. Then we do cross multiplication. 3 times 2 is 6. And then 2 times 1 is 2. Well, we have to get 8, so we have to plus it. That is equals to 8. So that is equal 8. 2 times 2 is 4. So we got 483. Thank you.
Talking a little multiplication right there with Pranshi. Great job that she did, and I know that she participated in the STEM Olympiad put on by KCSOS last year and did well at that. We do have phone tutors available most Tuesdays and Wednesdays throughout most of the school year. Phone numbers and emails are at the bottom of your screen periodically throughout the program. Right now, we are fortunate enough to have somebody from the Panama-Buena Vista School District Music Department with us. And we always love talking about the math of music. With us today is Andrew. How are you today, Andrew?
I'm doing very well. Very excited to be here.
Excellent. So where are you working? Because I know that you work for the school district, but do you work at one school or multiple schools?
I'm actually at 2 schools. I'm at Panama Elementary and Berkshire Elementary. I'm the band and orchestra teacher over there.
Okay. And I know that you guys have to know how to play a lot of instruments. Do you know how to play like all instruments, or are you very good at a couple of them?
I'm better at some than others.
So what would be the some that you're better at?
I'm primarily a clarinet player. That's my main instrument. I'd say I'm okay at the flute. I can technically play the cello and bass.
Okay.
Some require a little bit more work on my end.
Well, good. I know that Kiyo, he was talking a little bit off air. He also plays clarinet. So what will you guys be doing today?
Well, today we're going to be talking about sequence. And this is something that we use in both math and in music. So when I say the word sequence, Or do you know exactly what that is? Are you like, I think I've heard that word before, but not sure? Or have you never, like, you have no idea what I'm talking about?
I have no idea what you're talking about.
All right, well, we'll work with, we'll help to fill in some of those gaps. So we're going to talk about it in kind of two different modes today.
Okay.
We're going to start off with math and kind of relate it to how it relates in music. So in math, a sequence is just like a list of numbers or symbols that follow a specific pattern. That word pattern right there is the important word here, or function. So basically, it's a series of numbers that follow a set rule, more or less. Now, the easiest example is probably one that you learned in kindergarten. So what I'm going to do is I'm going to write some numbers here, and then I'm going to leave like one or two out, and you just tell me what you think they are based on the pattern. Okay? So the first one is this. So if you had to take your best guess, what do you think the next two numbers are going to be?
4 and 1.
4 and 1. And what makes you say 1 here?
Well, because in music, there's 4 beats. There's 4 beats.
Ah, you're thinking like a musician. That's a really great thing. Let's think like a mathematician for a moment.
Okay.
So in just looking at the numbers by themselves, because you're absolutely right. In music, it's always 1, 2, 3, 4, 1. And that's awesome. But in math, what comes after 4?
5.
5, yeah. So this is one of the easiest sequences that we learn when we're in kindergarten. 1, 2, 3, 4, 5, 6, 7. We can go on forever, right? So we're going to try a little bit. We're going to ramp it up just a little bit. Let's try. What do you think would come next?
9.
And how'd you figure that out?
Because you're skip counting by 2, so 1 to 3, 3 to 5, and 5 to 7, 7 to 9.
That is absolutely right. Counting by odds. Very nice. All right, I see you. Let's ramp it up even just a little bit more. Let's see.
It would be 25.
25, because we're counting by
5.
fives. So the rule is add 5 each time. So you're just breezing through these because you're recognizing right away that there's a pattern.
Right.
The numbers can really be any pattern. What's really important in sequence is that they follow the same rule each time. Now,
Right.
sometimes we can even add symbols to them. So let's see how we do with this one. What do you think would come next?
It would be 1000D.
1000D. Very good. And how did you get that answer?
You're timesing the number by 10, and you're also skip counting by 1 in the alphabet.
Yes.
Going up 1 letter.
Yes, absolutely. Great job. Great job. And you know, we even do this. We do this in our music as well. So you mentioned that you play clarinet, right?
Right.
So you're probably pretty familiar with rhythms and things like that, kind of working with those.
Mm-hmm.
Well, did you know that those also follow a sequence? So let's take this rhythm right here. What would we call that if we just saw, I know it kind of looks like a circle for those that are viewing, but what would we call this if we saw this in music?
I don't know.
Sometimes it looks like this as well.
A whole note.
A whole note, yeah. So this is a whole note, and if we represented that in a fraction, it would be 1 over 1. So it'd be a whole note, right?
Right.
And then we have this note, which is
Half note.
A half note. So 1
Over
2.
2.
Very good. Then we have the ever so famous
Quarter note.
quarter note, which is 1 over.
4.
Very good. And if we were to take it, let's take it 2 steps further. Okay? What would the next one in the pattern be?
A half note.
A half note? Oh, we already have a half
Wait.
note. What would this one be?
An eighth note.
An eighth note. You're absolutely correct. And how did you get there?
It looks like a TT, which is eighth note, but it's half of 1, and so it's not two eighth notes.
Very good. So if we were to use our music terminology, we got ta, TT, ta for rhythms and things like that. And that's a really good way to think about it. You can also look at it through the lens of math, in that the bottom number here. Do you see what the pattern is?
Yeah.
What is the pattern?
It keeps doubling every time.
Yeah, it keeps doubling. So 1 times 2 is 2, 2 times 2 is 4, 2 times 4 is 8. And if we had to use that deduction, what would be this final one?
A 16th note.
A 16th note. Very good. Very good. So, kind of transitioning now into the music portion of this. In music, we also have sequences, and that's a repetition and movement of a musical pattern at different levels. Again, that pattern is really the important part here. So you'll see I've written the beginning to a very famous piece of music called Beethoven's Fifth Symphony. And when you do a sequence in music, what you do is you take a little short snippet of music and you repeat it, but you change how high or low it is. Sometimes you give it to different instruments. Sometimes you give it, you play it loud versus soft. You play it high versus low. You do different things with it, which can create really, really cool effects when you stack them on top of each other. So we're going to listen to a little bit of that excerpt. And I want you to just listen for this pattern, the bum, 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 bum. Bum, 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 bum. So I want you to listen for how effectively Beethoven uses that pattern over and over again. Let's give it a listen. So he takes this musical pattern and he's going to change it up, and it will create this really, really cool effect. Repeat that pattern again and again. As you build, it gets faster and louder. You give it to more instruments, it's getting higher, more exciting. We'll pause it there. As much as we would love to listen to Beethoven all day, and believe me, we could, that's, I believe, all that we have time for today. But hopefully we learned a little bit about sequencing today.
Right.
There you go, nicely done. And I think I heard someplace in that piece of music how many times that is repeated during that piece. Do you have any idea how many times that has been repeated?
Oh, at one point I had counted it, and I have completely...
It's in the 30s, I think.
It's a lot. It is a lot within even just a minute of playing. That was only the first minute of that symphony, which is a much larger work of music that uses all the instruments of the orchestra.
All right. Well, Andrew, thank you for coming in this afternoon. Certainly a pleasure to have music and math and how they interact with each other.
Thank you for having me.
All right. We know that Kiyo is working on a math problem with Devin. It's a lengthy problem in more than one way. So, boys, head back to it.
Teleported right back in. That was amazing. Fantastic. All right, let's revisit back where we were, figuring out the dimensions of one of these rectangles. We figured out that the area of one of these rectangles is 4 square feet.
Right.
Through playing around with some of the other measurements, we came up with the idea that the length plus the width of one of these rectangles equals 4 feet.
Right.
We know that 3 times the length of one of these rectangles equals 8 feet. And we started talking about a way to figure out what L equals through one of these. And we started talking about how to find out what L is when 3 times L equals 8. Is there something we could do to both sides of this equation to figure out the value of the length of one of these rectangles?
Well, we have to get L by itself, so.
Right. So is there something we could do, knowing that this is 3 times L equals 8, right? So for example, if I said that 3 times something equals 15, what could I do to both sides to get whatever this is?
Divide it.
Divide both sides by what?
By 3.
3, right? So let's do the same thing over here. And when we do that, we know that the length will equal, well, what do we have here?
The width.
Well, no, this will still be the length, right? What is the value of the length that we figured out here?
The area.
Well, not quite yet. When we divided this side by 3, we got L by itself. When we divided 8 by 3, what does that get us?
That gets us,
and we don't even have to overthink this, right? This is, fractions are another representation of division.
Right.
8 divided by 3 is represented by the fraction 8/3. And so we can just leave it at that, 8/3 of a foot.
Right.
So we know that the length is 8/3 of a foot. And we can convert that into a mixed number, right? We can say that that's the same thing as 2 2/3 feet, right? And that's fine, because we know that if we multiply this by 3, we'll get 8, which was the length of this oval rectangle. And this also gives us information that we could plug into these other pieces here. It's probably going to be easier to plug 8/3 into this, right? Because what we're going to now say is 8/3 plus something equals 4. Now, if we're thinking about adding a fraction to get to a whole number, what can we do to the whole number to make it easier to add to?
The whole number?
Especially if we're adding thirds.
Right.
Is there something or another way we could represent 4 whole?
4 over 1, or we can make it into thirds.
Yeah, let's do that. So it's much easier to add thirds to thirds. 4 whole is equivalent to how many thirds?
12 thirds.
12 thirds. So 8/3 plus how many thirds equals 12 thirds?
4 thirds.
4 thirds. And what that means is the width of one of these rectangles is 4/3 of a foot. Now, here's the check. We need to see and make sure that 8/3 times 4/3 is equivalent to 4 square feet. And since we know that this is the length and this is the width, all we have to do is multiply those together. Have you explored how to multiply fractions yet?
Yes.
Okay, how would we do that here?
Just go straight across?
It's the best way to work with fractions, right? Because it's just that operation across the way. So let's multiply the numerators and the denominators and see what happens. All right? 8 times 4?
32.
32. Now 3 times 3, this is where it gets a little tricky here, right? 3 times 3 is what?
9.
So 32/9. Is that equivalent to 4 square feet? No. So there's something else we may need to explore here, or something to dive into. But playing around with a problem like this, it's not straightforward. But you get to try some things out, see what works through. One other consideration that we didn't even explore.
And we're going to let you guys explore that in just a moment, because as we said, this is quite the problem.
It's a big one.
So we're going to let you guys continue working on it, but right now we're going to check out what's going on this week at NASA.
The first Artemis robotic launch to the moon, an Artemis lunar robotic rover is halfway built, and an up-close look at a volcanic moon. A few of the stories to tell you about this week at NASA. United Launch Alliance and Astrobotic are currently targeting no earlier than January 8th for the launch of Astrobotic's Peregrine lunar lander to the moon. NASA payloads aboard the lander aim to help the agency develop capabilities needed to explore the moon under Artemis. This is the first commercial robotic launch to the moon's surface as part of our CLIPS initiative and Artemis program. The team building our Viper lunar rover is about halfway through the build. The mobile robot will land at the south pole of the moon in late 2024 to search for ice and other potential resources. The critical information it provides will teach us about the origin and distribution of water on the moon and help determine how we can harvest the moon's resources for future human space exploration. Our Juno spacecraft recently flew by Jupiter's moon Io. The spacecraft captured imagery and other data as it passed about 930 miles above the surface of the most volcanic world in our solar system. This was the closest flyby of Io that any spacecraft has made in over 20 years. For more about Juno, go to nasa.gov/Juno. While stationary during Mars solar conjunction, our Curiosity rover on Mars captured a 12-hour sequence showing its own shadow moving across the planet's surface. Plasma from the sun can interfere with radio communications during Mars solar conjunction, so missions hold off on sending commands to Mars spacecraft during that time. That's what's up this week at NASA. For more about what else we're up to, check out nasa.gov.
Always interesting things going on this and every week at NASA. Kiyo, a 6th grade student from Highgate Elementary, working with Devin on a pretty good problem. So boys, where are you at right now?
Well, we explored another way to think about this. We realized that if we're able to say that 3 of these lengths is equivalent to 8 feet, well, we could look at the top of this rectangle too and come up with the same conclusion with the widths. And Kiyomasa was able to reason that 5 of these widths is also equivalent to 8 feet long.
Right.
So if that's the case, then we know that 3 lengths is equal to 5 widths. And we found earlier that the length of one of these rectangles was 2 2/3 feet, right, or 8/3. So with that, we can plug that in to this equation to see if we can come up with a similar approach here. So if we know that 3 lengths is equal to 5 widths, we can plug 8/3 in for 3.
Right.
So we'll do 3 times 8/3.
Right.
And again, it's multiplying with fractions, so that's a little bit easier for us to work out, right? How would we do that?
Just put a 1 under.
We're going to convert 3 into a fraction, 3 wholes, and then we'll multiply across, correct? So we
Right.
have 3 times 8 here,
24.
and then we have 1 times 3,
3.
which is
8.
8, which is great. I was not going for the rhyme. That just happened. Spontaneity is key.
Yeah, we know all about that.
If I was going for it, you'd know it.
Hey, just like when we were saying it was a lengthy problem, right? We did.
See, that had depth to it.
So, are you guys feeling pretty good with this
We're
one?
getting there. So now if we know that 3 times L here is 24,
Right.
and we know that 24 is equal to 5 widths, then what can we do to get the width by itself?
We divide it.
We're going to divide both sides by
5.
5. So 24 fifths is going to be our approach to explore this width here. So this is another effort that we can try here. We'll put 24 fifths. And again, we can convert that into a mixed number, 4 and 4 fifths. This is a type of problem. It's my favorite type of problem because it's not a direct approach. You can try some things out, work through it, see what works and what doesn't until you get to a point. Now, there
I've
are
got
other problems
another
that we'll see.
great problem for you.
This is a great one.
All right, because that one we're going to put to bed for right now, and then Kiyo can keep working on that because there's a lot of different ways that you can go about solving that problem. So I've got a problem that is similar to that.
Okay.
So this one, so write this out. This is completely going to be able to get done in the amount of time that we've got. So if 4C plus 12 is equal to 28C, what is the value of 100C?
All right. So there's a lot to play with here. How would you start off with breaking this down?
Well, we'll try to get the C by itself by dividing 4
Well,
divided by
we
12.
could. So if you divide by 4, would you have to divide all of this by 4? Every part of this equation? Or is there a way to make this a little simpler before we bring division into the case?
Maybe there's a simpler way.
So let's take a look at any like terms, right? Within this equation, do we have any terms that do share a coefficient and a variable?
C.
C, all right, so we can try to isolate the C terms by themselves.
Right.
So is there a certain number of C I could take away from both sides? So I get 12 by itself.
You can bring the 28 to the left side or bring the 4 to the right side.
Which would you prefer we try? Which do you think would be easier to work with afterwards?
Bring the 28C to the left side.
So if we do that, we have to take it away from this side. And what operation would that entail?
That would entail what's it called?
Are we gonna add it or are we gonna subtract it?
We're gonna subtract it.
Okay, so we're gonna have to subtract 28C from both sides. So that means we're gonna have to dip into some negative territories here. If we were to bring 4C over so that C is on its own over here, how much would we have to take away from each side?
Just on 4.
4C, right? And that's gonna be a little easier to work with because we don't have to deal with negatives, right? So if I have 28C and I take 4C away, how many C's do I have left?
24. Yeah.
24. Now, that's out of the picture. We still have our 12 remaining here,
Plus
right?
12, yeah.
So we have 12 equals 24C. Is there something I could do to figure out how to get C by itself?
You could divide it by 24.
Or
we can
12.
divide by 24. You're absolutely right. So we can divide by 24, and what that's going to tell us is that C, one instance of C, is going to equal,
Negative 12.
well, we're not subtracting here, right? This is a division instance to get C by itself. So we have 12 divided by 24, which, again, fractions and division are one and the same. So if we look at this as a fraction, is there a way that we can maybe reduce this fraction to a simpler form?
1/2.
1/2. Now, we found how much C equals, but the question asked us how much 100C equals.
Okay.
So if I have 100 halves, what would that total be?
100 halves, that'd be 200.
Well, that would be 200 halves to get to 100. But if I have 100 halves, what would the total be? So if I'm looking at this, I'm really thinking about this as 100 times C, right?
Right.
So I have 100, and I'm multiplying this by what the value of C is, which in this case is?
Half.
1/2. So 100 times a half,
It would be 50.
50. So 100C in this instance where we started at 4C plus 12 equals 28 gets us
To 50.
to 50.
There you go. Nicely done. So come on over, Kiyo. So, a couple of things went on today. You had a very busy day, right? We did a lot of mathematics today. So I want to talk to you a little bit first about the clarinet and the music over there. So when did you start playing clarinet?
At the beginning of 5th grade.
Okay, so you've been doing it for about 1.5 years now.
Right.
And what do you like most about the clarinet?
It's just fun to play, and I enjoy it very much.
Good. So did that make sense, the math that you guys were doing and how that applied to the music and the math and the patterns and sequence that you guys saw going on?
Right.
Good. So you learned a lot today. What's one thing you learned today?
I learned that homework can be tricky, and in general, it's very tricky. But I did learn a lot from this, and I can put this into class. And
Good, because what you guys were talking about with the length and width and taking a look at these different patio tiles, that brings us up to another one of your homework problems. And we didn't even get to this one today. But this is where, and some kids that are viewing might go, hey, you know what, I've got that same problem, where you've got large rectangles, they're squares, but you've got large squares, small squares, and then you've got rectangles, and another problem that you need to work on. So what you can do is during the week, you can call us back. Maybe we can help you out with that problem. Sound good?
right.
All right. Did you have fun today?
Yes.
That's the most important thing right there. So we do have phone tutors available until 5:30 most Tuesdays and Wednesdays. As a reminder, we will be ending at the end of March, right around spring break. So until then, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Edison International, Valley Strong Credit Union, Panama-Buena Vista Union School District, and the Kern High School District. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.